wave, or we can say a wave is always associated with moving particle called matter wave. Okay. But this matter wave is not electromagnetic in nature. Always remember, this matter wave is not EM wave. It is a different type of wave. Means if a particle is moving, it will move in the form of wave. And uh, there will be a packet of energy, a packet of different wavelengths will be associated with the particle, right? We have formula of only one wavelength, but if you study Huygens uncertainty principle, you can understand with a particle there are more than one wave associated with a particle. Okay, but in general you can say that there is only one wave associated with a particle according to its momentum. Always remember, if momentum of the particle is high, wavelength will be low. Okay, remember this matter wave is not EM wave. Matter waves are not EM waves. Remember. Okay. Now the formula, the wavelength of a de Broglie wave is given by, you can say wavelength is equal to h by p. H is Planck's constant and p is, what is p? Momentum. And p is momentum of moving particle. Okay, copy this. अभी भी बच्चे लेट आ रहे हैं यार, पता नहीं क्या. Everyone please copy this. With a moving particle there is a wave associated known as matter wave. Matter wave is not EM wave, it is a different wave. So if a particle is moving, it will move in the form of wave. Always remember. So you can write different formula. This wavelength of this wave is given by lambda is equal to h by p, and at the place of p you can write mv because it is momentum, and at the place of momentum you can write under root 2 mke. Hopefully everyone remember relationship between momentum and kinetic energy. You remember or not, bacho? Everyone remember this, how I wrote under root 2 mke, or anyone have doubt? See, it is very easy. I'll tell you how we got it. Kinetic energy is equal to mv square by 2. Now you multiply and divide by m. So you'll get mv upon 2m, mv whole square upon 2m. So you got p square by 2m. So you can write p is equal to under root 2m ke. Like this you can write de Broglie wavelength. Like this you can write under root 2m ke at the place of momentum. So you can conclude this, lambda is inversely proportional to momentum. Lambda is inversely proportional to under root of kinetic energy, and lambda is inversely proportional to velocity. Velocity of particle. Understood everyone? आगे बढ़े बच्चों, click on yes. If everyone understood this, click on yes. Okay. Okay. Now, please ignore this sound. Right. No. The smallest wavelength measured is possible is that of gamma rays. Okay. Always remember this. And the wavelength of matter wave associated with the microscopic particle like electron, proton, and neutron alpha particle is the order of Armstrong. Okay. The wavelength of matter wave associated with microscopic particles like electrons, proton, neutron, and alpha particle etc is of the order of 10 to the power minus 10 meter. Matlab Armstrong, right? Remember this. Copied this much? Okay. If you want more time, everyone copied? Anyone want more time? No? Okay. So what we have learned till now, if a particle is moving, there will be a wave associated with the particle. And the wavelength of that particular wave, which is known as matter wave, is given by lambda is equal to h by p, where p is momentum. Okay, bacho? Now write next heading, de Broglie wavelength with the charged particle. De Broglie wavelength associated with the charged particle. With the charged particles. Bacho, as everyone knows that if we put a positive charge Q, it will by default it will flow from higher potential to lower potential. Am I right, bacho? So if you want to accelerate a positive charge particle through a potential difference V, you will get kinetic energy. Gain in kinetic energy is equal to Q delta V. Do you remember that? Everyone remember this or no? Click on yes. If you remember this, click on yes. Okay. If you put a positive charge at higher potential, it will accelerate towards lower potential by default, by itself. Okay. So gain in kinetic energy is always equal to Q delta V. Now lambda we have already written lambda is equal to h by p, and at the place of p we can write 2m ke. So only for charged particle you can write under root 2m q delta v. Now what is delta v? Where delta v is accelerating potential. Where delta v is accelerating potential. जैसे हम किसी पॉइंट मास को छोड़ देते हैं तो ग्रेविटी के अंदर उसकी काइनेटिक एनर्जी बढ़ती है ना बच्चों. जैसे अगर हम किसी पॉइंट मास को छोड़ दें अंडर ग्रेविटी, so it will start falling under gravity and its kinetic energy will increase. In the same way, if you release a charged particle under a certain potential difference, its kinetic energy will increase. Understood? Understood, everyone? So mainly 4 different types of charged particle will be there in our problems: electron, proton, alpha particle, and deuteron. So by putting value of m and q, you can make shortcut. Like for electron only, if you try to find wavelength associated with the electron, you can put mass of electron and charge of electron. After putting value of h, 6 point, what is value of h? 6.6 na? 10⁻34, and put mass of electron 9.1 into 10⁻31 into charge in electron 1.6 into 10⁻19 into delta V. When you solve this, you will get 12.27 divided by under root delta V Armstrong. But remember, you can use this formula only for electron now, because you have used mass of electron, charge of electron. So very quickly you can get answer if you use this formula for electron, because in exam we don't have that much time to put value of m, q and h and calculate it. Understood, everyone? In the same way, you can write this formula for proton. For proton only, you can write lambda proton 0.286 divided by under root delta V Armstrong. You can use this formula only for proton. For alpha particle only, you can write 0.101 divided by under root delta V Armstrong for only alpha particle. Okay. And for deuteron, do you know deuteron? It has mass double than proton and charge equal to proton. It has charge equal to proton, but mass is double of proton. Deuteron has 1 proton, 1 neutron. And hydrogen have only 1 proton. Armstrong. So if possible, you can keep these formulas in your mind to calculate very fast de Broglie wavelength of charged particle. You can get answer very fast if you can keep these formulas in your mind. Okay. Copied, everyone? Copied, everyone? Now write de Broglie wavelength with a neutron. De Broglie wavelength for the neutron. Right? For neutron. Neutron is uncharged particle. For neutron only. It is uncharged. So that you will start from very basic h by p. At the place of p, you can write under root 2m ke. Now always remember, kinetic energy of a neutron can be given as Boltzmann constant into temperature. Okay, only for neutron you can use this, because the kinetic energy of neutron will be proportional to temperature. If you increase temperature, kinetic energy of neutron will increase. Imagine a independent neutron. So independent neutron will move faster if temperature is high. Okay. So for neutron, you can use this formula, h upon under root 2 m kt, where k is Boltzmann constant. Understood, bacho? Remember, wavelength of neutron is inversely proportional to under root temperature. Important result. For a lot of objective questions, you may get direct question from here. You can use this for neutrons. तो एक जैसे न्यूट्रॉन एक पार्टिकल है, अगर वो चलेगा तो उससे रिलेटेड वेवलेंथ ये होगी. ठीक है. अब लिखो डी ब्रॉगली वेवलेंथ डी स्मॉल आता है. डी ब्रॉगली फॉर एटम्स ऑफ गैस, मतलब किसी गैस के एटम भी बच्चों पता है वेव के फॉर्म में आगे बढ़ते हैं, सीधे नहीं चलते, वो ऐसे वेव के फॉर्म में आगे चलते हैं. तो ये वेव कौन सी होती है? डी ब्रॉगली वेव. और इसकी वेवलेंथ कैसे निकालेंगे? नाउ फॉर गैसियस एटम बच्चों, काइनेटिक एनर्जी इज गिवन बाय 3/2 kT. अब आप में से कुछ बच्चों को याद होगा कि काइनेटिक एनर्जी ऑफ मोनोएटॉमिक गैस कैन बी रिटन लाइक दिस, एवरेज काइनेटिक एनर्जी ऑफ मोनोएटॉमिक गैस. So you can write lambda is equal to h by p, h by mv, h by under root 2m ke, and at the place of kinetic energy you can write 3/2 kT. So 2 and 2 will get cancelled and you get formula for gaseous atom. Three m kT. Understood everyone? Till this any problem बच्चों? दर्शिता यहाँ तक कोई दिक्कत? सबको समझ आया? Okay. Okay, thank you everyone for responding. विनायक आप सब समझ आ रहे ना? विनायक, कोई भी चलते हुए पार्टिकल के साथ एक वेव एसोसिएटेड होती है जिसे हम मैटर वेव कहते हैं, और ये मैटर वेव डी ब्रॉगली वेवलेंथ मैटर वेव ईएम वेव से एकदम अलग है. ठीक है, चलो अब मेरे साथ लिखो, राइट कैरेक्टरिस्टिक्स ऑफ मैटर वेव्स. एवरीवन राइट characteristics of matter wave. It is very important. Matter wave represent the probability to find particle in space. Because particle is moving in the form of wave. Particle is not moving in the straight line. That's why with the help of matter wave, you can predict position of a particular particle in space in vertebrae. बहुत बेटर तरीके से आप पार्टिकल के स्पेस में होने का पता लगा सकते हो मैटर वेव की मदद से, क्योंकि पार्टिकल सीधा नहीं चलने वाला है, वो वेव के फॉर्म में चलने वाला है. ठीक है, जैसा कि मैंने पहले भी बोला, मैटर वेव आर नॉट EM वेव. मैटर वेव EM वेव तो बिल्कुल भी नहीं है. ओके, नाउ मैटर वेव means de Broglie waves are independent from charge. चार्ज से इंडिपेंडेंट है. समझ आया? मींस चार्ज का मैटर वेव्स की वेवलेंथ पे कोई फर्क नहीं पड़ता. मैटर वेव्स आर इंडिपेंडेंट फ्रॉम चार्ज. चार्ज का मैटर वेव की वेवलेंथ पे फर्क नहीं पड़ता. वो बात अलग है कि एक्सेलरेटिंग पोटेंशियल बदल जाती है और काइनेटिक एनर्जी बदल जाती है. ठीक है, जब आप एक्सेलरेट करते हो ना चार्ज पार्टिकल को, तो वहां पे जरूर चेंज आ जाता है, लेकिन एक बार चार्ज पार्टिकल चलने लग गया तो फिर उसकी वेवलेंथ को चार्ज से फर्क नहीं पड़ता. फॉर्मूले में भले चार्ज दिख रहा है, लेकिन आप लोग याद रखेंगे द वेवलेंथ ऑफ ऑफ मैटर वेव इज इंडिपेंडेंट फ्रॉम चार्ज. डजंट मैटर the particle is charged or not. So there is a matter wave associated with the every particle. It doesn't matter that particular particle have charge or not. Okay, right? Point number 4, the phase velocity of matter waves can be greater than speed of light. अब ये थोड़ा ज्यादा हाई लेवल का पॉइंट हो गया. क्वांटम फिजिक्स में तुम लोग ये सब सीखोगे. ठीक है, मैटर वेव कैन प्रोपेगेट इन वैक्यूम. Matter waves can very easily propagate in vacuums. Okay, hence they are not mechanical waves. तो मैटर वेव ना तो EM वेव्स है और ना तो मैकेनिकल वेव्स है. ओके, याद रखोगे. Now sixth, very important, mark a star on point number 6. Only those circular orbits are stable. Only those circular orbits are stable whose circumference is integral multiple of de Broglie wavelength. Means suppose this is orbit around nucleus, an electron is revolving in this orbit. So electron will revolve in the form of wave like this. Electron should make standing wave around the nucleus. So when electron is revolving around the nucleus, it will make a standing wave. So right now, how many waves completed? 1, 2, 3, 4. So we can write 2 pi r is equal to 4 lambda. In general, we can write, in general, according to the point number 6, we can write 2 pi r must be equal to n lambda. Then only orbit will be stable, where n is an integer. Understood, bacho? Understood, everyone? Very important for 12th school exam. Point number 6 is very important for the school exam. That's why I marked a star on it. Okay. आगे बढ़ते हैं. Yeah, let's write one more point related to this. The number of de Broglie wave associated with nth orbit is n. Okay. So any doubt in the characteristics of matter waves? याद हो जाएगा विनायक? इजीली याद हो जाएगा बेटा? मुस्कान याद कर लोगी? श्रद्धा?
Yes, sir.
Shraddha, are you there?
Yes.
Shreya? Okay. Very good, very good. Aryan? Anvit?
Yes, sir.
Any doubt in the characteristics of matter wave? Any doubt? No? So what is matter wave? Matter wave are EM wave or mechanical wave? Or both not? Matter wave is not EM wave and it is not mechanical wave also. Matter wave can propagate in vacuum. Okay. If you are trying to explain a 10th class student what is matter wave, what you will say? अगर आप एक क्लास 10th के बच्चे को मैटर वेव एक्सप्लेन कर रहे हो तो आप क्या बोलोगे? कि जब भी कोई पार्टिकल चलेगा तो वो कैसा चलेगा? सीधा चलेगा या वेव के फॉर्म में चलेगा? बोलो जल्दी. Whenever a particle will move, it will move in the form of, come on, it will move in the form of wave. This matter wave means all every particle have a wave nature. Every moving particle has a wave nature, because if wave can behave like a particle, it means particle can also behave like a wave. De Broglie ने ये बोल दिया without any experiment. Understood बच्चों? De Broglie said this without doing any experiment. Okay. Now, अब हम इसकी कुछ बारीकियां समझते हैं. ठीक है? देखो important points related to de Broglie wave. बच्चों, if a particle is moving, then the wavelength associated with the particle is lambda is equal to h by p, and you can write it h by mv. Now assume we have two different particles of same mass. We have two different particles of same mass. So, but they have different velocity. What will be the ratio of their de Broglie wavelength? Two particles of same mass have different velocity, let's say v1 and v2. What is ratio of their de Broglie wavelength?
V2 by V1.
Correct. So we'll write lambda 1 is equal to h upon m v1 and lambda 2 is equal to h upon m v2. So lambda 1 upon lambda 2 is equal to v2 by v1. Understood, bachcho? Because if mass is constant, then wavelength is inversely proportional to velocity. Okay. If mass is constant, then wavelength is inversely proportional to velocity. If mass is constant. Can you draw a graph between wavelength and velocity? What should be the nature of graph between wavelength, de Broglie wavelength and velocity? Come on, fast.
Rectangular hyperbola.
Rectangular hyperbola. Very good. It will be rectangular hyperbola. The nature of graph if mass is constant. Now I have one doubt, bacho. Write an example, write a question. Graph between lambda and velocity for two particles of mass m1 and m2 is shown. अरे कौन है मम्मी ये देखो यार कौन मूर्ख है भाई अच्छे से लगा दो दरवाजे पंखा भी चला दो और वो देखो किसकी गाड़ी कहाँ यार ये बाइक लगाई थी तो होटल में से निकला वो मूर्खता की परिकाष्ठा करते हैं यहाँ के लोग This is M1. This is mass M2. Okay. अभी आपको सही ऑप्शन ढूंढना है select correct ऑप्शन पानी दे दीजिए बताइए बच्चा Can you handle this question? Through mic, give me answer. You can send me message also.
Option 2.
How?
Lambda is inversely proportional to mass also.
I want easier explanation. Can you give it? Can you give easier explanation? Let's drop a perpendicular from wavelength axis. So what point A and B suggest you? Wavelength is same, right? Could you understand that? M1, V1. This is V1, this is V2. And again, lambda is equal to H, M2, V2. Wavelength is same. Could you understand that? Wavelength is same. It means M1, V1 must be equal to M2, V2. If you drop a perpendicular line, it means you get same value of wavelength for both the graphs. Could you understand that? This perpendicular line trying to explain you wavelength is same. बच्चों बताओ समझ आया कि नहीं आया? अगर हम एक ऐसी परपेंडिकुलर लाइन ड्रॉप कर दें इसका मतलब ए और बी पे वेवलेंथ सेम है. हाँ? Click on yes if you understood and click on no if you have any doubt. And please भगवान के लिए अपना माइक यूज करा करो. भगवान के लिए अपना माइक यूज किया करो. ये समझ गए कि सेम है? Okay, that's good. That's good. Almost everyone clicked on yes. Very good. Very good. So wavelength is same, and you can see that V1 is greater than V2. लेकिन उनका प्रोडक्ट इसलिए सेम होना चाहिए. M1 V1 must be equal to M2 V2 because they have same wavelength. That's why this product must be same. And now we already knows that V1 is greater than V2. So this should be greater than 1, right? V1 by V2 should be greater than 1 because V1 is greater than V2. So that's why M2 by M1 should also be greater than 1. M2 by M1 should also be greater than 1. It means M2 is greater than M1. Understood? This is how we can conclude. Answer is 2. Pranit gave correct answer. Pranit. Only Pranit gave correct answer. Very good. Very good, Pranit. Now let's move towards our next concept. It will be very interesting, but believe me. This chapter, I'll bring very good questions for you. यहाँ पे समझ आ गया आपको अभी? अगर दो पार्टिकल हैं और मास और वेलोसिटी के फॉर्म में अगर उन्होंने बात की तो आप हैंडल कर लोगे ना? Can you handle if they are talking about the de Broglie wavelength and giving mass and velocity? Could you manage? Can you manage now? Okay. I believe you all are saying yes. Now, example 2, if I say you make a graph between lambda and p momentum, what will be nature? Through mic, please tell me. We can use this formula, h by p. What should be the nature of graph?
Rectangular hyperbola.
Rectangular hyperbola.
Very good, very good. B, make a graph between lambda and 1 upon velocity. Now what should be the nature of graph?
Straight line.
Very good, straight line. See why? Because lambda is equal to h upon mv. So at the place of lambda, you can assume y because you are keeping lambda on y-axis. And h by m is the constant. So it is c. Suppose it is a k. H by m is a constant. Suppose it is k. And at the place of 1 by v, you can assume x. Because you are taking 1 by v on x-axis. So you get a equation y is equal to kx or y is proportional to x. For this, you must get a straight line. Understood? Any doubt? Graph between lambda and 1 by v must be straight line for NEET student. Very important. For NEET student, it is very important. I believe IIT means maths student will handle it easily. Aryan, बहुत ध्यान से देख ले, okay? Now, can you make a graph between lambda and under root kinetic energy? Graph between lambda and under root kinetic energy. What should be the nature of graph, bacho?
Rectangular hyperbola.
Rectangular hyperbola.
Okay, because inverse, the relationship is inverse. That's why it should be rectangular hyperbola. Right? Option number D. What should be the nature of graph between lambda and 1 upon under root kinetic energy?
Straight line.
Straight line.
because
Straight line.
lambda is equal to h upon under root 2m ke. So at the place of lambda, you can assume y. H upon under root 2m is a constant, and 1 upon under root ke, you can put here x. So it should be straight line. रट लो अच्छे से. Okay. Now I want to give you a bigger task. Repeat all the graphs for large mass and small mass. Write homework question. Draw graphs between lambda and 1 by v for large mass, large and small mass. Second, draw graph between lambda and under root kinetic energy for large mass and small mass. Third is draw graph between lambda and 1 by root ke for large mass and small mass. Your homework. In the next class, you will explain me. Shreya, you please remind me I gave this homework, okay? So that we can discuss in the next class.
Yes, sir.
Okay. Now, write one more very important point. Conclusion of uncertainty principle. When a particle exhibit wave nature. बच्चों तुम लोग की स्कूल खुल रहे हैं? It is
Yes, sir.
associated, मतलब स्कूल जाओगे?
सर अभी तो 1 महीने बाद.
कोई नोटिफिकेशन आया क्या? Wave packet rather than a wave. कितना मजेदार स्टेटमेंट है. With a particle, there will be more than one waves associated with a particle rather than one wave. बहुत डीप है बच्चों ये, ठीक है, बहुत हाई लेवल है. मैंने अनसर्टेनिटी प्रिंसिपल तो नहीं पढ़ाया आप लोगों को, लेकिन उसका कंक्लूजन भले ही याद करा दिया. कीप इट इन माइंड. ओके, अंडरस्टूड? So these are important points related to de Broglie wavelength. These all are important points related to de Broglie wavelength. I have more important point, I think, but you can understand. You can handle these those important points. Like if you get in numerical, like you get a question in which two same charged particle accelerated with different accelerating potential, what will be the race of their de Broglie wavelength? Two charged particles has same charge and mass accelerated by different accelerating potential. What is ratio of their de Broglie wavelength? बताइए. क्या लिखेंगे आप? lambda is equal to h upon under root 2m q delta v. Am I right? So they have same mass and charge, but different accelerating potential. Delta v1, and for lambda 2, you will write h upon under root. Am I right, बच्चों? सही लिख रहा हूं ना? So when you divide lambda 1 by lambda 2, you will get under root delta v2 by delta v1. Bachcho, am I right? Can you handle these situations? Okay. Now write Davison and Germer experiment. बच्चों डी ब्रॉगली ने विदाउट एनी एक्सपेरिमेंट ये बोल दिया कि पार्टिकल वेव की तरह बिहेव करेगा, लेकिन डेविसन और जर्मर दो ऐसे साइंटिस्ट थे जिन्होंने डी ब्रॉगली की बात को परखने की कोशिश की. उन्होंने सोचा अच्छा अगर मैटर वेव की तरह बिहेव करेंगे तो फिर अगर हम बहुत सारे इलेक्ट्रॉन्स को बॉम्बार्ड करें जो कि वेव की तरह बिहेव कर रहे हैं, इंटरफेरेंस भी दिखाएंगे. इंटरफेरेंस जैसा वाईडीएसई में होता था ना. डू यू रिमेंबर बच्चों यंग्स डबल स्लिट एक्सपेरिमेंट? इंटरफेरेंस राइट. सो डेविसन एंड जर्मर थॉट if matter is a wave, then matter should also follow destructive and constructive interference principle. तुम लोगों को कैसी लगी ये बात? Matter can follow interference. Yes, if they are wave, they will have to follow. Understood? They'll have to behave like wave. So Davison and Germer performed an experiment. In this experiment, they used an electron gun. From electron gun, they sent a beam of electron towards nickel crystal, and from nickel crystal it got reflected, and we collected this beam in a detector, right? And we wrote condition of constructive interference. So when we got constructive interference, the intensity should be very high, and when we are getting destructive interference, the intensity should be very low. Let me explain you this experiment. Let's write Davison and Germer experiment. Very, very important for class 12th. Right? Davison and Germer experiment. Very, very important for class 12th. It is used to study scattering of electron from a solid to verify wave nature of electron. Electron is a particle, right? And it will sometimes act like a wave. Now write a beam of electrons emitted by electron gun is made fall on nickel crystal cut along cubical axis. I'll try to explain you this, but you need to have some patience. Nickel crystal acts like three-dimensional diffraction grating. Copy this much. Done? Copied everyone? Click on yes. Okay. Now I'll show you diagram. This is the diagram, bacho. As you can see, this is electron gun. An electron beam is coming on the nickel crystal. This is nickel crystal, and this beam got scattered, and detector will catch this beam. Okay, this is theta, this is phi, and this is also theta. So remember, 2 theta plus phi must be equal to 180 degree. Okay, we'll talk about Bragg's angle. Have patience for that. Angle of scattering and Bragg's angle. We'll talk about both the angles. Theta is also known as glancing angle. Phi is known as angle of diffraction. Done? Make this diagram, bacho. Make same to same diagram as it is. Theta is known as Bragg's angle, also known as glancing angle. Also known as angle between incident beam and the plane. Angle between incident beam and the plane. And phi is angle of diffraction. Make a beautiful diagram. It should look like this only. Now I will tell you secret behind this. Completed diagram? Take your time. Shreya, done?
Yes, sir.
Pratik? Sinchana, Vinayak, done?
Yes, sir.
Okay, okay. Okay, now write the secret behind it. What is actually happening, I'll try to show you. Instead of electron beam, you imagine light wave. And this kind of structure is inside nickel structure. Okay, I'll tell you what is happening. It is very interesting. But you suppose this is the picture inside nickel crystal. Imagine this is first electron beam. Okay, and This is another electron beam, the second electron beam. Which is parallel to previous beam. Okay. This beam will get reflected from here. This will get reflected like this. So can you determine path difference between both the beams? Yes, it is easy. It is very easy to find path difference. Drop a perpendicular here. And drop another perpendicular here. This distance is small d. This distance is small d, bachcho. Right? And this angle is theta. So what is this? D cos theta or D sin theta? Come on, Vinayak, tell me. ये तो D cos theta हो जाएगा ना, ये D sin theta होगा. Am I right? This is also D sin theta. So can you tell me what is the path difference between the two beams? Say 2D sin theta. Am I right? What is the path difference, bachcho? Come on. Through mic, please tell me what is the path difference.
2D sin theta.
2D sin theta. Correct. Now, why we got this angle as theta? Let me explain. Draw a straight line here. If this angle is theta, bachcho, this angle is 90 minus theta. That's why we got this as theta. And this is angle of diffraction, where theta is also known as Bragg's angle. Okay. Understood, or shall I explain it again? I'll explain it again. See what is happening. बच्चों इमेजिन करो दो लाइट बीम्स आ रही हैं. ये एक लाइट बीम आ गई और यहां से रिफ्लेक्ट हो गई. लाइट बीम बोल रहा हूं, इलेक्ट्रॉन बीम. अंडरस्टूड. और एक और इलेक्ट्रॉन बीम आई. दिस इज अनदर इलेक्ट्रॉन बीम and got reflected like this. Now, can you help me to find path difference between them? Beam must be parallel. Now they are looking parallel. But I want to find path difference between these two. What I'll do, I'll drop a perpendicular here, and same perpendicular I'll drop here. I'll stretch this, I'll get a triangle. We'll get a triangle here, right? If this distance is d, so this distance will be d sin theta. Am I right? So the lower wave traveled 2d sin theta extra. एक तो इतना एक्स्ट्रा चला है और इतना एक्स्ट्रा चला है. Am I right? Lower wave will travel 2d sin theta extra. Understood? हेलो. हाँ भाई, करता हूँ कॉल बैक. अभी खत्म नहीं हुआ लेक्चर, टाइम बदला था थोड़ा. 15 मिनट और पढ़ाऊंगा. 10-15 ज्यादा 15 मिनट. ठीक है. तो 1 बजे है ना मेरा अगला लेक्चर. चलो, नहीं हो तो सब मैं करता हूँ ना. चल बाय. ठीक ठीक है, ठीक है. शाम को कर लेते हैं. बाय. ना बच्चों, अभी इसमें कोई डाउट बच्चों कि लोअर वाली जो वेव है, लोअर बीम have traveled 2d sin theta extra because this much path is same, because till this they traveled same path, and after this also they are traveling same path. So the path difference is only this thing. Now am I clear?
Yes, sir.
Okay. I hope everyone understood what is happening inside nickel crystal. Because of reflection from the nickel crystal, there should be a path difference. Delta x means path difference of how much? 2d sine theta, where theta is which angle?
Glancing angle.
Bragg's angle. Where theta is Bragg's angle, also known as glancing angle. Okay, understood or not? Very important for IIT mains. Very important, bachcho. Already asked 3 times. 3 times came exam. Okay, and in 2008 when I wrote IIT mains, this question was there, and I did a mistake. I'll tell you what mistake I have made. I'll tell you. But for right now, you understand what is path difference. 2d sine theta is the path difference. Now these two beams are received by the detector. Could you understand that? Detector will receive these two beams. Understood, bacho? So diffracted beam of electron is received by the detector, which can be positioned at any angle by rotating it about the point of incident. Right? The diffracted beam is received by detector, which can be positioned at any angle by rotating it about point of incident. Now, right, the energy of incident beam of electron can be changed by changing voltage inside electron gun. It will be a 5-mark question. That's why we are writing everything in so detail. Okay. Copied this much. If you want more time, message me. If you want more time, click on go slower. And if it is done, click on go faster or click on yes. Okay, that's good. I believe you all are writing with me. Okay. Now the very important point. Next point is very important. According to classical physics, the intensity of a scattered beam of electron at all scattering angle will be same. But Davison and Germer found that the intensity of a scattered beam of electron was not same, but at different angle of scattering. What I mean to say, you can write only this: the intensity of scattered beam is different at different angle. Davison and Germer found that. Okay, बच्चों. Davison and Germer found that the intensity of a scattered beam is different at different angle, and they plotted a graph. They start plotting a graph between intensity and accelerating potential, because this is an experiment, right? They can change accelerating potential here at electron gun. They can change accelerating potential. They can keep changing accelerating potential, and at detector they are checking intensity. Understood? What is use of detector? So they made a graph between intensity of beam and accelerating potential. And they got graphs like this. When they use 44 volts, they made 4 different graphs. Then they increased accelerating potential up to 48 volt. They got graph like this. But at 54 volt, they got maximum intensity. This is phi. At 50-degree angle of scattering and 54 volt, they got maximum intensity. At phi is equal to 50-degree and 54 volts, they got maximum intensity. Maximum intensity means what? Constructive interference or destructive interference?
Constructive.
Correct. So we will write, I think we can delete this graph, not required. Please make all the 4 graphs. This graph is the most important one. Means at the 50-degree angle and 54 volt accelerating potential will get constructive interference. It means path difference would be equal to an odd multiple of lambda by 2 or even multiple or multiple of lambda, integral multiple of lambda.
Integral multiple of lambda.
Correct. So we can conclude that when phi is 50-degree and accelerating potential is 54 volt, we will get condition of maxima. Means we can write 2d sine theta is equal to n lambda. Understood, everyone? Huh? So now, but we have value of phi. We want theta. What will do that? What will do? See, I wrote here 2 theta plus phi is equal to 180 degree, right? 2 theta plus phi is equal to 180 degree. By using this, 2 theta plus phi is equal to 180 degree. Put phi as 50 degree. You'll get theta as 65 degree. Okay, now put at n is equal to 1 and theta is equal to 65 degree. And we know that d is equal to 0.91 Armstrong. We know that d is equal to 0.91 Armstrong. The wavelength should be, after calculating all this, we'll get wavelength equal to 1.65 Armstrong. Who calculated this wavelength? Say Davison and Germer. Who calculated this wavelength? Davison and Germer. Understood? बच्चों, am I audible?
Yes, sir.
जबकि डी ब्रॉगली ने तो पहले ही बोल दिया था ना. डी ब्रॉगली already said that lambda is equal to 12.27 divided by under root delta V for electron. Do you remember this? So if we put accelerating potential, how much? What accelerating potential we used here?
54 volt.
If we use 54 volt here, we will get almost same wavelength. Means theory of de Broglie was correct. Understood? It means de Broglie gave correct theory. Any doubt, bachcho? Hence, the theory of matter wave is 100% correct. Understood, bachcho? Any doubt in that? You can revise this from YouTube. If you have any doubt, you can ask doubt from me from using WhatsApp. Okay. I believe everything is very clear to you. Now we'll meet in the next class and we'll solve a lot of questions related to this. We have completed atoms. We have completed photoelectric effect. Today we have completed de Broglie matter wave. Now in the next class, we'll complete X-ray, and after next class, we'll complete nuclear physics. So we need only 2 more classes to complete class 12. Okay. Now semiconductor is also left. I think we need 2-3 classes for semiconductor, but we'll do semiconductor later.